So this tutorial is about the IPython interactive widget infrastructure, which is a new feature. And the presenters are Brian Granger, who's a physics professor at Cal Poly San Luis Obispo. He's been working on IPython since 2005 and wrote the first version of the IPython Notebook a few summers ago, along with Jonathan Frederic, who's a graduate physics student at Cal Poly and has been working on IPython for about the last year. So without further ado, I'll hand you over to them. Thank you very much.
Fantastic. Whoop. We live? Thanks so much, Thomas. Welcome to everyone. Welcome to another PyData, Silicon Valley. It was 2 years ago that we had our first PyData. It was a small event, I think maybe around 50 people. We met at Google. And needless to say, PyData has grown a lot in the last 2 years, and we're all really excited about that. I'm going to spend a few minutes talking about a few practical things related to the tutorial, and then John is going to jump in and cover some of the basics of the notebook. So the first thing is installation and the repository for the tutorial materials. And the first link here, can we get there you go. So the first link there is our GitHub repository that contains all the IPython notebooks that we'll be going through today. And you can download that here as a zip file if you don't have Git installed, or you can just do a local Git clone of that repository. And we will keep flashing that URL up.
Well, the URL is right here too. Tutorial materials. This is a short and bit.ly.
Great. So we also have the persistent bit.ly link there. And then the next thing that we want to do is spend a few minutes making sure everyone has IPython installed on their laptops so you can follow along. And to assist in that, we have a few other IPython developers here. There's Thomas, who introduced the tutorial. And also Min is right here as well. And so we're going to spend about 3 to 5 minutes with Min, Thomas, and John walking around, helping people if you need help getting things going. Probably the simplest way, or the way we're recommending installing IPython for this tutorial, is through Continuum's Anaconda Python distribution. And if you Google for Anaconda Python, you can find that very easily. It is a free Python distribution with all the dependencies you need. And once you download that and install it, it's a double-clickable installer. You will need to run 2 other things at your terminal on Mac or Linux, or in the command prompt window. A program on Windows, and that is you'll need to run conda update conda and then conda update IPython. And if you don't run that, you will be using IPython 1.1, which is an older version of IPython and contains none of the features that we'll be talking about today. IPython 1 does not have the widgets, and so you will be out of luck. And so if you start to use the notebook, trying things out, and it's just not working, or things look really different, you're using an older version of IPython and you need to update. And if you're having trouble getting things installed, just raise your hand and one of the 3 will come around and help you get that going. Probably the simplest way to double check which Python you have running is to open up a terminal and just type IPython. And when IPython starts, it will display the version number here. That should say IPython 2.0 for the version that the updated version that you'll get with Anaconda. Another help over here on the right. Another thing that you can do to sort of the next level of testing is to actually start the IPython notebook. And the way that you'll do that is to type IPython space notebook. And as of IPython 2.0, the notebook allows you to browse different directories on your file system from the notebook dashboard. I can show you what that looks like. Let's go over here. So I actually here have started the IPython Notebook in my home directory. And so I actually, oh, can we get back to the browser over there? Ah, right side, both sides. So when you start the IPython Notebook with the 2.0 version, you'll actually now see directories listed as well as notebooks. And so you can click on, here's a notebooks directory, and you'll see that there's notebooks within that. So you can actually browse your file system. IPython 1 didn't allow you to browse the file system. This is another way that you can test to see that you're using IPython 2. If you open up the notebook and you can't browse your file system, you're using IPython 1, and you want to make sure to update. No, there's not. So the question is there a way, so if I click on the home button here, is there a way to go higher than that? And there's not. The main reason we made that choice is for security. We want you to be able to run the notebook server at a particular point in your file system and below. We don't want you to be able to creep up and access your Etsy password file and things like that. More help? While everyone's getting this set up, also wanted to thank the sponsors of IPython and of PyData. In particular, obviously want to thank Facebook for having us here on their campus for these 3 days. IPython these days has a number of funding sources. Our two main funding sources are the Sloan Foundation and Microsoft, so we want to give a huge shout out to them. We also have money from the NSF and the Simons Foundation, and then Rackspace provides us with very generous hosting for a number of different things that we run, including NBViewer, which we'll be talking about at some point here. All right, well, why don't we go ahead and dive in, and I'll hand things off to John. Oh, one other thing, don't want to forget this. If you go to the ipython.org website, on the right hand here, under the community section, you'll see the help chat room. The help chat room is a public HIP chat room, and you can enter your name, and we will have different IPython developers in this chat room. So if you want to ask a quick question there during the tutorial, we definitely encourage you to do that. And you can see different people joining right now. So that's another resource that we will use for help during the tutorial. And with that, I'll hand things off to John.
Thanks, Brian. So everybody's all set up now, right? We got IPython 2.0, hopefully. The first thing that I want to make sure is that you have started the IPython Notebook in that directory with the tutorial content that you downloaded from that bit.ly link that was on the screen earlier. With that, you can follow along, and all the exercises will be there. So what is the IPython Notebook? Well, the IPython Notebook is an interactive computing environment that allows you to author Python content, view the results, embed rich media, and interactive widgets that manipulate the Python backend. There are three main components to the IPython Notebook: the Notebook web application, the kernel, and the Notebook file itself. The Notebook web application is what you see in your web browser once you start the IPython Notebook server. It allows you to edit the code, run code, see results of computations, create, what?
Full screen browser.
Is that good?
Yeah, it looks good. Perfect.
Do a little bit more. So it allows you to edit code, run the code in the browser, see the results of your computations, embed math equations using LaTeX, embed interactive widgets and manipulate your Python. It allows you to start parallel computing clusters. The second part of the IPython Notebook is the kernel. And when you install IPython, by default, a Python kernel is installed. And that's the language that you're using when you're interacting with the notebook. But there are many other kernels. They're not all listed here, but these are a lot of them. We have a Julia kernel, an R kernel, a Ruby kernel, a Haskell kernel, a Scala kernel, a Node.js kernel, and a Go kernel. Right now, those aren't super easy to install. It's kind of a pain in the butt to get them working. But with 3.0, we're planning on doing a major refactoring of that, and it should be really easy to install additional kernels. IPython should automatically detect that, and you'll be able to launch any language that you want directly from your dashboard. The last piece, the notebook document, it's actually a flat file. It's a JSON document, so you can open it with any text editor and view the content of your notebooks. Notebooks themselves are documents that are basically an array of cells. Cells can have, there are four different types of cells: markdown cells, raw cells, heading cells, and code cells. The heading cells can have different levels, and that lets you build like a hierarchical document. Notebooks themselves can be exported to static formats, so you can export your notebook to like a plain HTML document or to a LaTeX document and then convert that to PDF and share that with your friend who doesn't have IPython Notebook installed. Right now, if you do that, widgets aren't exported, so the interactive widgets that we're going to see today, when you export, your friends won't be able to interact with the backend, obviously, because there is no backend. But in the future, we're working on, for 3.0, a static widget store. So when you export, there'll actually be somewhat a small amount, limited amount of interactivity. So let's start talking about the notebook basics. So you have your notebook server running in the directory with the tutorial content, and you can follow along. The first thing that you'll see when you start the notebook is the dashboard. And I think Brian talked about that a little bit. So I'll just skip through that. But the dashboard allows you to, that's where you create notebooks. It's where you can open notebooks. It's where you can view the running notebooks. There's actually a running tab, and that will show you notebooks that are running in directories other than the directory you're in. It shows them in the entire tree. And if a notebook's listed as running, it will have a red button next to it that allows you to shut down that kernel. When you click shutdown, if you're on the running tab, the notebook will be removed. But on the main notebook tab, if it's not running, it will have a delete button next to that notebook, and you can actually delete the notebook by clicking on that. It will ask you for a confirmation. And here, there's also a clusters tab on the dashboard, so you can start parallel computing clusters. So a quick overview of the notebook UI. There's a menu. That's what you see here at the top, a toolbar, and then the notebook area, which is where all of your cells are listed. New to IPython 2.0 is a modal system. There are two modes, edit mode and command mode. It's kind of like Vim. One mode, you're running commands on the entire document. The other mode, you're actually editing the content of individual cells. If you're in edit mode, you'll see a thin green border around the cell that's currently selected. And if you're in command mode, you'll see a thin gray border around the cell that's selected. If you're in command mode, you don't want to try to type a whole bunch of stuff because things will explode. Cells will get deleted and moved, and it's just not a good idea. You can enter edit mode by double-clicking on a cell. So you see when I double-clicked on that cell, it unrendered the markdown HTML, and a code mirror editor popped up. You can execute the cell by clicking and holding Shift and then Enter. and that will re-render the content. Anything that you do with the keyboard, you can do with the mouse too. So if you are in edit mode and you need to enter command mode with the mouse, you can just double click or single click outside of the cell area.
Also point out the edit command mode indicator in the menu bar.
Yeah, that's a good point. In the top right-hand corner here, you see there's a small little pencil icon, and that's just an indicator that it's okay to type, that you're in edit mode. If you're in command mode, that indicator goes away. You see there's no indicator there. The idea with the mouse navigation is that any cell can be selected by clicking on it. The toolbar and menu items that you use will act on the currently selected cell. And with the keyboard, when you're in edit mode and when you're in command mode, there are two completely different sets of shortcuts. You can view these by clicking on Help, Keyboard Shortcuts. That will bring up a dialog. To enter into edit mode, you can highlight a cell, click Return, it's edit mode, Escape, goes back into command mode. If I do Shift Return, that runs it and moves to the next cell. You can also do, for basic navigation, up and down key, but also J and K work when you're in command mode. You can save the notebook by clicking S in command mode, and change cell types by clicking Y for code cell, M for markdown, 1 through 6 for different heading cells, and T for a raw text cell. So moving around the document using J and K, if you hold Shift when you do that, or sorry, if you hold, Control, when you do that, you can move the cell too. So it's the same direction as J and K normally does, but it drags the cell with it. And the code cells we already covered. So there are a couple exercises for you guys stored under the notebook exercises document back at the index for this tutorial. And the first one is just create a notebook and create a couple of cells that contain simple Python expressions. Practice shifting between command and edit mode a few times, and going back to edit existing cells. And then try using time.sleep to view the indicator in the top right-hand corner here to show that the backend is computing. When the backend's computing, you see this will become solid. It will be a solid circle. Yeah, so just a few minutes, 2 or 3 minutes, maybe. Do that. Actually, I'm going to just do it right here. What's that?
Here, I can show you.
Brian can help. Yeah, if you need any help navigating to the directory with the downloaded content, just raise your hand.
So if you go to github.com /IPython /IPython
Okay.
in/depth.
Oh, okay. Yeah, somebody brought it up.
It was already.
Okay, yeah, maybe I can put it on that.
Okay, so.
Click on download zip.
Okay, navigate to the directory that you download. So, okay, is this inside the, okay, yeah. Okay, now do IPython space notebook. That will launch the notebook. No, there you go. Enter. Oh, notebook. Awesome.
So two other keyboard shortcuts that are really useful when you're in command mode. A is for insert cell above. B is for insert cell below. That's really useful. There are also in the toolbar here, there are arrows here to move cells up and down. And the plus button here does insert cell below if you don't want to use the keyboard shortcuts for that. How do you get into edit mode? So so here I'm in command mode. If I want to get into edit mode from the keyboard, I just press return. Press enter, yes. If I press escape, it hops out. Another way to get familiarized with the user interface, under help, there's a user interface tour, and that user interface tour will actually walk you through some of the user interface things like this. And so that's another way of exploring this, and it goes through command mode and edit mode as well. Yeah, another question. Yes. Yeah, the question is there a way to insert a cell above other than from the command line? And it's basically the command line, or I guess we don't have insert cell in the edit menu. So yeah, it's A. Yeah. All right, please raise your hands if you have other questions, and we'll have people come around. And all right, John, you want to?
Yeah, I'll come with you. Okay, I'm going to go ahead and walk you guys through the exercise if anybody's stuck. So here, this is the directory where the index is sitting. I'll go ahead and click New Notebook. And then this first cell that shows up is the code cell. So here I can type directly in the cell my Python code. So I can do from time import sleep. And then I can call sleep 2 to sleep for 2 seconds. And hitting Control-Enter executes that cell. And you see the indicator in the top right-hand corner was solid when I did that. And also the asterisk on the prompt, where the number is, it's an asterisk instead of a number while it's executing. Okay. So on to the next exercise. Go back into that notebook and add at least one cell of each type. Practice the following cell operations: moving up and down, cut, copy, and paste, and merge and split. I'll give you a couple minutes for that.
Show people what's available in the edit menu.
Yeah, that makes sense. So before you get started with that, let me fill you in. You can do cut, copy, and paste operations from the edit menu. So there's cut cell, copy cell, and then different paste operations. You can also do it from the toolbar. You see the scissors, the copy, and the paste operation icons. But you can also use it, do it using command mode. So in command mode, it's the standard keys: X the cut, C the copy, V the paste. So I can X, V, X, V. And also from the menu, you can change the cell type. So if you don't want to use the hotkeys, you can cell type, choose one.
Okay.
I know that these shortcuts are saying like Shift D should.
And one of the benefits of command mode is that for most operations in command mode, you don't need a modifier key. So there's a few where you do need command or shift, but when we say it's X, C, or V, or A, or B in command mode, it's just that key. It's not command, Control A or Control B or something like that. So it's it's actually a very efficient way of working because you don't need the modifier keys for most of those actions.
Okay, I'm gonna help you guys with this next, or walk you through this next exercise. So I can insert a cell by going to the menu and clicking insert and then insert cell below. That creates a cell. I can also click B while I'm in command mode. Clicking B will insert a cell below the current cell. I can also click A to insert a cell above the current cell. And I can also click this little plus icon here in the toolbar. That will create a cell below the current selected cell. So to change cell mode, I can do from the menu, cell type, and choose the type that I want. So this is a markdown cell. Type hello world. I can also do it from the toolbar. I can choose cell heading 1, for example. But I can also do it using command mode. So keys 1 through 6 are different heading keys. So I can do 2 for a level 2 heading. And then one important thing to notice here is if you edit the text in the cell and you're in markdown mode or it's a heading cell, when you escape out of edit mode into command mode, it remains unrendered. So you actually have to render that cell. Once again, you can do Shift Enter to run that cell, and that will render it. Shift Enter creates a cell below. You can also do Control Enter to execute the cell in place. Or you can click the play button to execute the cell and move down to the next cell.
John, go forward.
Move forward. Okay. So I think that's it for our introduction. We're blowing through time pretty fast here. So I'm going to hand off to Brian, and he can cover the rich output display framework.
All right, thanks, John. So we wanted to go through that material to get everyone on the same page. This tutorial is a little bit of a challenge. In some ways, it's oriented beginner intermediate. At the same time, we are going to climb very steeply, and by the end, be in very advanced material where we're going back and forth between HTML and JavaScript code and Python, and so buckle your seatbelts. So anytime you want to compress the vertical space of the notebook, in the View menu there, you can toggle the header of the toolbar. So I'll run in that mode. The first part of the vision of widgets in IPython is actually something that has been around from the beginning with the notebook, and that is rich output. And the idea here is that the Python programming language allows objects to declare their textual representations. And that's done using this special _repr_ method. And any object that defines that method, when you return that object from an expression or you print that object, that method is called to compute the textual representation. What we've done with IPython is generalize that idea of a representation of an object to other formats. And IPython 2.0 supports the following formats listed here: HTML, JSON, PNG, JPEG, SVG, and actually a PDF as well. As of IPython 3.0, we're really moving towards general MIME types. So basically, any MIME type that you can imagine, a Python object can declare how that MIME type representation can be computed. And this is a lot of what has helped the notebook be used and really leverage a lot of modern web technologies, even without widgets. And so I want to really separate these two things, that what we're talking about now doesn't qualify as widgets. When we're talking about widgets, we're not talking about the mere display of a rich output. We're actually talking about a bi-directional communication between the front end in the notebook user interface and the back-end Python kernel where the code is running. So in your mind, when you think of rich output, think of one way with the kernel sending a rich representation to the browser to display. With widgets, you get the bi-directional communication. So you click on a button in the user interface, that can send data back to the kernel, which does a computation, which sends data back to the front end. That's more of what we mean by a widget, and we'll go into a lot more detail about that. So in this first notebook, talking about rich output, we want to show you how you can leverage IPython's existing APIs for rich output. And the first thing is the built-in display function. Display is like print, but for these rich representations. And there's a few important points here. First, calling display on an object will send all possible representations to the notebook. So if you have an object that has a PNG representation and a LaTeX representation, and you call display with that object, we compute both of those representations and send them both back to the browser. It's up to the front end to determine which of those representations it wants to display. The reason we do this is that we want IPython notebooks to be useful in many different contexts, right? Maybe you're starting out, you're running something interactively, and in the browser, it makes sense to have a PNG representation. But later, you want to convert the notebook to a LaTeX document. And in that context, the best representation to use is LaTeX. This is why we, in general, compute all the representations. That enables the notebook to be useful in all of those different contexts and to let the context determine which representation is most appropriate. Second, these representations, all of them, are stored in the notebook document. So when you have an object with a JPEG representation, we encode that in the JSON. We store it in the notebook document. So when you email that notebook document or you version control it on GitHub, that data stays with the notebook. When you open it, use it in other contexts, that data is still available. In general, the notebook will use the richest available representation. And the richest available representation is roughly, the more interactive is we consider richest. So JavaScript would be the most richest. Down to the bottom would be a plain text representation. Images, LaTeX, HTML are in between. I forget the precise order, but I think HTML is above images. And I don't remember the ordering between LaTeX and HTML. We also have display functions that work for computing a single representation. So these are display pretty for textual representations, and then display HTML, JPEG, PNG. And we have display objects that can be used with the display functions for displaying a particular type of content. So for example here, we're going to say from IPython.display import image. And the image object knows how to compute JPEG and PNG representations and send those back to the browser. So here, I'm going to pass a file name, and this is the IPython logo to this Python object. So here I build, let's import that. And then if I return that image from an expression, we automatically detect, the IPython kernel automatically detects that that object has that representation. We compute it, send it back to the browser, and the browser displays it. You can also get the same effect by passing that object to display. The benefit of display is that you can call display multiple times in a given cell. It's just like print, right? You can call print inside a loop. You can call it inside a function. Display works the same exact way. An image can also be displayed from raw data or a URL. So here, we're going to grab the Python logo from the python.org website. And we also have an SVG Python object which knows how to compute the SVG representation. So here's an SVG image embedded in the notebook. You can see what this offers. It really allows you to tie together the computational power of a language like Python with all the benefits of the modern web, right? I mean, if you can put something on the page in a web browser, you can build a Python object that's capable of generating that content and tying computations to it. There's an important distinction between embedded and non-embedded images. Remember I said, in general, when we compute these representations, we store them in the notebook document. The one case where that's not true is if you build an image object and you pass a URL, the data that we're persisting to the notebook at that point is the URL, not the image data itself. Right? And so you need to be aware, if you're pulling an image from a URL, by default, that image is not stored in the notebook. You can force it to be embedded in the notebook down here with embed equals true. And an example of this here is that there's a webcam at UC Berkeley here. There's a URL that gives the current image. And there's a static version, an embedded version. And if you, let me see, how are we doing this? I guess the API is a little different there. If you give it the URL, it is embedded. If you say URL equals that URL, embedded is false, so just the URL will be embedded. If you give the URL and embed equals true, it will again embed the image data into the notebook. I'm not going to run through that example in detail. HTML. So we have an HTML display object. Again, that is a Python object that knows how to compute the HTML representation of an object. So here is a Python string that has some HTML. If we pass that to the HTML object, we've got an object that can then be displayed, and its representation in the browser is just that exact HTML injected into the DOM of the notebook. IPython also has the notion of magic commands. And magic commands are an extension to the Python programming language. You know that you're using a magic command because it will begin either with a single or a double %. A single % is called a line magic. A double % is called a cell magic. And a perfect example of a cell magic is this cell right here. We say double % HTML. And again, this is not valid Python code. This is an extension to the Python language that IPython has had since the beginning, focused on efficient interactive usage. And it allows you to just type HTML code in the rest of that cell. IPython also has cell magics that, for a number of other purposes, for example, if you've ever used Python, we have a double % Python magic that allows you to type Python code into a cell, and then we automatically compile that code and build a function that you can then call. So it's a nice way of calling other languages. We also have a double % R magic function that allows you to just type R code into the IPython notebook. I should note that this is different from our native R kernel. The native R kernel allows you to run R code without the double % R syntax at the beginning of the cell. So when I run this, you get the same exact thing. You can imagine what the implementation of double % HTML does. It simply passes the string to an HTML object and then returns the HTML representation. JavaScript. It may seem a little odd that we consider JavaScript to be a representation of an object. JavaScript is a programming language. Most of the other representations are visual things that you can look at. However, JavaScript obviously can put things on the page and build interactive and visual elements. And so let's look at that. We have a JavaScript object. That JavaScript object takes a JavaScript source code as a Python string. When we run it and then display it, we run that code. Right? We also have a double % JavaScript cell magic, which does the same thing. Right? And so the notebook becomes a really nice environment for sort of playing around with JavaScript and HTML, where you may want to be pulling data from Python. Right? Here's a longer example. So here we are going to use jQuery's getScript function to load D3.js from a CDN. And so we run that. And one thing that's important here is that when you're writing JavaScript code that gets injected into the browser, into the notebook like this, you can take full advantages of the various libraries that IPython itself uses. Those libraries are jQuery, jQuery UI, Bootstrap, Require.js, MathJax, Backbone, and I feel like I'm forgetting others, but CodeMirror. So you have a really full-featured sort of mini development environment to write and run JavaScript code in. Here, I'm going to use a double % HTML cell magic to throw some CSS on the page. Again, when I run that, there's no direct output. The DOM elements that have been put on the page for that style tag aren't themselves visible. But when I run the following JavaScript code, which creates other elements in the DOM, those elements will pick up the CSS styling that I've done in that previous cell. So here's, this is just one of the standard D3 examples. And when we run that, you just get the D3 rendered in the browser. Yes?
Can we include other JavaScript libraries and frameworks?
Absolutely. So you can do that in one of two ways, well, really one of three ways. So one, if that JavaScript library is available on the web, you can load it using jQuery's getScript, or you can also load it using Require.js. Another way is that IPython has a directory NB extensions that's available in your .ipython directory. You can put static files there and then have those loaded onto your page as well. So there's quite a bit of flexibility there. LaTeX. We have two display objects for putting mathematical equations on the page. The first is a math object. And here, the idea with the math object is that you pass a string that has LaTeX, and the math display object adds the LaTeX delimiters around that. In this case, it's the dollar signs. And then we bring it back to the notebook, and it's rendered using MathJax. The LaTeX object has one difference from the math object in that you have to specify your math delimiters yourself. And so in this case, the math delimiters we're using are begin and end equation array. And so here we can run, and we see that we can get Maxwell's equations. We also have a double % LaTeX magic that does the same thing. It's important to note that there's two different ways that you can get LaTeX rendered in the notebook. One of those ways is using output, which is what I'm showing here. Another way is if I create a new cell, hit M to create a markdown cell, return to edit it. Here is an equation. And in a markdown cell, you can also just put dollar signs, and you're going to get formatted LaTeX as well. And I guess the way that I look at it is when you're just writing prose and you want to include mathematics, do that in a markdown cell. When you want to programmatically generate LaTeX, right, where you have some Python object or maybe an expression tree of Python objects where it makes sense to programmatically generate LaTeX from that you want to display, that's where you would use the LaTeX or math display objects. Audio. IPython makes it easy to work with sounds interactively. We have an audio object. You can pass a URL that has an audio file. And so you see an HTML5 audio player embedded in the notebook. The audio object also takes a data keyword argument where you can actually pass it a NumPy array or a list of raw audio signal. We normalize that and convert it to a WAV file. And so here's an example of two different audio frequencies that are added together. And when you play that, you hear the beat frequencies. I don't know if you can hear that. Thank you. So you can hear the beat frequencies there. Just the HTML5 audio support. Underneath the hood, the audio object is actually an object that just has an HTML representation. And it's just that. Yes?
Do you support local paths, not only URLs, like file,
For the audio object?
For any images, audio?
Yes, that works for images. That definitely works for audio. I don't remember if it works for HTML and JavaScript, but we're happy to have pull requests. So. And actually, I'm thinking we don't have file support for HTML and JavaScript, and I think that would be a good thing to add. Again, this is the web. If you could put it in an HTML tag, you can write an object that has that representation. Here is a YouTube video object that we have, and the representation of that is an embedded YouTube video. So here's a little video that has an example of the IPython Notebook being used at the first ever White House hackathon. And with a little bit of trickery, you can also inject local videos. And I'm not going to go through this example in any detail. Here, we're base64 encoding a video and actually putting it in that base64 encoding in the tag. And when we run it, it does indeed work. And so, if you have a simulation or something that has a local video that you want to embed in the notebook, that's also possible. You can also embed external sites, right? An external website in the context of the browser is just an iframe, and we have an iframe object, and when you run that, you get an embedded website. So here's the ipython.org website. I should note in the notebooks that you're looking at here, this example is python.org, and python.org sets headers that disallow iframe embedding, so that example won't work. Just add an I, so it's ipython.org, and that will work. We also have a file link and file links object, and that is designed to create a link in the notebook to another local file. So in this case, here, when I pass a file name, in this case, it's the name of this actual notebook. And if I click on this, it will actually open that file in the browser. File links allows you to basically create an embedded listing of an entire directory hierarchy and all the files in those. Rich output and security. This is where things get fun. The IPython Notebook allows arbitrary code execution in both the IPython kernel, which is where your code runs in the backend, and in the browser through HTML and JavaScript. I want to repeat this. The entire goal of the IPython Notebook is arbitrary code execution, right? Take that back to your security folks and tell them, can I use this web application whose sole goal is arbitrary code execution on our servers? Right? It's obviously something you need to be aware of. To make matters worse, the IPython Notebook has a JavaScript API that allows JavaScript to run code in the kernel. Right? What this means is that if you have a Python object that has a JavaScript representation, that JavaScript representation has full access to running arbitrary code on your system. Is everyone following this? This is extremely important. Here's our approach with this. One, this is the goal of the IPython Notebook. We're not going to hide this, right? But we want you to be aware of what you're dealing with, right? If you want to think of this as a loaded gun, this is like gun safety. It's knowing when the safety should be on. It's knowing not to point it at other people. The one promise that we're making to you is that that won't ever happen when you merely open a notebook. Right? When you open a notebook, arbitrary code execution should not happen. The only time that should happen is when you hit Shift Enter, Control Enter, or click the Run button in the toolbar. At that point, you should know that anything is possible. Right? You could run Python code that runs JavaScript code that pulls a JavaScript library that reruns Python code that does rm-rf $home. Right? But honestly, anytime you run Python code, that could be the result of the operation, right? That doesn't need to involve the notebook. That is entirely possible with any Python script or library you download from the internet and that you use. A few important points. One, when you run code in the notebook, and that is a deliberate action on your part, all rich output will be displayed. You have to trust the code that's running to not display output that is going to do something harmful on your system. When you run a notebook, rich output is displayed only if it does not contain security vulnerabilities. We are using the Google Caja library to actually inspect the HTML code that is generated in output, and if that output is deemed to be dangerous or untrusted, if it has script tags, things like that, we don't run it when you simply load the notebook, right? So if you generate a notebook that has JavaScript representations and you send it to a friend, when they open it, those JavaScript representations will not run. They're going to have to re-execute the notebook to get that to show up, right? This is really important. Or there's one other case where you can get all rich output to run when you open a notebook, and that is if you have trusted a notebook. And the definition